Okay, so you guys had questions with example 4 and 5, right? So let's go over example 4 step by step so that you see where the 2 is coming from. So the ones that they say, where is 2 coming from? So let's see. All right. So the first you need to realize is the first time you apply integration by parts, you end up with something that looks like this. All right. That's the first time you apply integration by parts. Now you still need to integrate this piece here. So this piece here, you still need to apply integration by parts, right? Because I can't ask you for an integral and then in your answer you leave in an integral, all right? I don't want that. So you need to give me something without an integral sign. So you need to do by parts again. And if you do it again, you end up with something like this. So this whole integral here is this, all right? So if you apply by parts there, you get this result. Now we need to substitute this here, all right? So this guy here is going there. What happened is, remember you had this piece here, minus e to the power x goes x, it's just this piece here, all right? And then this result here is this result that you got from applying integration by parts here, all right? Very, very important. Now, if you notice it, this piece here, which I marked star, is exactly the same integral that I asked you in the beginning, all right? They're exactly the same. So what do? You take this whole thing here, this integral, you take it to the left-hand side. All right, remember it was minus, it's going to change to plus. Therefore, you have integral of e to the power s and x plus integral of e to the power s and x. It's just two of those, all right? If you add the same integral twice, you just have two of those integral, all right? That's where the 2 comes from, because you just add two of the same thing. And if you divide all 2 by 2, that's how you get to this result here, all right? It's as easy as that. And again, like I said, I use C1 because if you divide all 2 by 2, there's going to be 2 there. And this whole thing is going to be divided by 2. And these 2 days will cancel with each other. Notice it because it's C over 2. That's why I just use a new constant called C1, which I say is just equal to C over 2. All right. Okay, is the student happy? All right, you say when you mention the inverse, okay, I still need to explain, someone wanted me to explain example 5, all right? All right, someone is asking me, why do we have C? The answer is simple. You go back to the initial integral and ask yourself, is this a definite integral or an indefinite integral? It's an indefinite integral. It means at the end, you're going to have plus C. And where does C come from? The plus C, you add it when? It comes when you take all the integrals to one side, all right? So if you notice it, my notation again. All right. So at this stage, you don't have a plus C because there's still an integral on both sides. But once I start to take everything to one side, then I need to introduce plus C. And again, because it's an indefinite integral, it's a mod. Can you mute your mic and see there's someone? Let me just on my side. All right, please, when you join the group, just mute your mic, all right? We're not interested in your conversation that you're having there. All right, so after doing that, someone asked me about the inverse function. Is that going to be, let's just go to example 5. So I'm just looking at the question again. You say when you mention the inverse trig functions that you will ask about, does this apply to both definite and indefinite? The answer is yes, all right? Because you've done fundamental theory of calculus part 2, I can ask you a definite integral. Definite integral is just me adding a bound, all right? So Obviously, if you add a bound to a problem, it means they need to give you some final answer, some numerical value, all right? But if there's no bound, then they're going to give you a function at the end, and then they're going to say plus c. So the answer is yes, all right? You will definitely get either an indefinite or definite or both, but you must know both of them. Any other question? All right, you see for question 5, we continue to answer the question, how do we know that we are supposed to use substitution? All right, let's see. How do we know if we're supposed to use substitution? All right, let me get my pencil again. Maybe a different color this time. All right, so first thing is, you see it's an inverse function, and we've done Leate, and you've identified it, you can use integration by parts. So you choose your u to be the inverse function, and because it's a single function, your dv is just the invisible one, all right? So it's just 1 times dx, all right? And if you differentiate tan inverse, it says 1 over 1 plus x squared. If you integrate 1, you just get x, all right? Now you apply integration by part. Look at this carefully. Because there is this bound here from 0 to 1, I need to apply it by part, and I make sure that I put the bounds as well, from 0 to 1, and then from 0 to 1. Where is u substitution coming from? Because at this step, you're not done. Do you agree? Yes, this we can simplify, but how about this piece here? You see, you still have this piece. I told you if you see a bound 0 to 1, it means I need a number. So I need a numerical result, all right? But now you're giving me an integral, so at this step, you're not done. You still need to solve this piece, you need to integrate this. And to integrate this, you know it's u substitution. Someone asks, why is it u substitution? Now you need to be careful. This is not by parts again. Why? Because if you differentiate this, the agree is going to get way complex, all right? That's the first thing. We said if you differentiate your u, it should get simpler. But looking at this, if you differentiate, it doesn't get any simpler. And then integrating this, obviously, is what we're discussing now, which is why we say u sub. Why u sub? U substitution arises when you look at the function you're trying to integrate. You notice that if you let u to be one piece of the function and you differentiate it, it will give you another function, all right? So in u substitution, if you have f of x and g of x, if you let u to be f of x, if you differentiate that, it kind of cancels out with g of x. So if I let u to be 1 plus x squared, already I know if I differentiate that, I'll get 2x, and there's an x there at the top, which is going to cancel with that derivative of u, all right? So that's how I know is u substitution. Another way to write this as 2 separate functions is just to say x, you put brackets, you say 1 over 1 plus x squared. Now you've successfully written this as 2 functions, and it becomes very easy. Now ask yourself, what is u? Obviously, remember I said don't use u, just use a new variable, since we've already used u here in the beginning when you did your integration by part. Just use a new variable called t. But in mind, you know you're doing a u substitution, all right? So if you let t to be, obviously you want t to be this piece there at the bottom, 1 plus x squared. Because if you differentiate that, you get a linear function, and you see there's a function outside there which is going to cancel with that derivative. That's why it's u substitution. For those of you that forget to use substitution, please go and revise use substitution. Remember, in calculus, we're going forward, we're not going backward, all right? So once we hit integration by part, we assume that you know your fundamentals of calculus and you understand use substitution. So if you've forgotten those, please go and revise, all right? And obviously, because it's a definite integral, you need to do change of bound. Initially, this bound here means x is 0 and x is 1. But now, because you're doing change of variable from x to t, you need to also change your bound. So if x is 0, t is 1. If x is 1, t is 2. Notice it, the new bound now is from 1 to 2. All right. Even though here you see u, technically you could have just used t there, dt. And here also it's just t. And so everywhere you see u, just put t. All right. And if you integrate, very important, if you integrate 1 over x or 1 over t or 1 of any variable, you get lean absolute value. Very, very important, absolute value, all right? The reason I'm saying that is because one of your bounded can be a negative value, all right? Very important. One of the bounded can actually be a negative value. And if you fail to put the absolute value sign, you know for yourself there's no lean of a negative value. You end up telling me that the answer is infinity or it does not exist. And then you're going to lose marks. Right? I hope you're happy with it.